Okay, so first of all I want to thank 1718. This is a fantastic idea. As soon as I found out about it, I really wanted to do this for everyone. How many people have ever heard of QFD? Couple? Okay. Well, you're all going to be experts by the time we're done with this. It's really something really easy to do. Okay, this is, we actually have components on our team, and this is an excerpt out of our manual, which is how to make better toast, since we're the flying toaster engineering. And we officially wrote this up last May after our second year team. Sources, really good sources. Top Shops by Robert Wilson and John Scott is a wonderful book if you could read it. It has many good things there on how to put together an award-winning team that produces things. It's more from a manufacturing point of view, but does help out. And other literature that's really good is How Useful is QFD from John Sanford, Team 1038. I think it was 2005, 2004 time frame he wrote that. And then to Ed Debler from Thunder Chickens and with Flying Toasters now. It's from Ford Motor Company. He's had very good experience and he helped me out putting this together. My background is I was a cutting tool engineer for 15 years. Loved it. Unfortunately, the automotive in our area started to disappear in the 2000, and in 2005 I had a chance of moving into a whole different field, being an educator at the high school, and I thought this is going to be the place to be until the storm was over. Needless to say, it is the place to be, but the storm is long over and gone, and I don't want to move. It's fantastic being there. So taking my experiences, I try to draw on that for my students. Well, this slide here is really cool in the fact that it's completely blank. What I like to generally do is have people take a blank piece of paper and draw a line on it. So anybody have pencils? Yeah, somewhere on the paper, draw a line. So I'm going to try and do that. Let's see here. You do the same thing. Come on. Gotta love technology. Okay. Pen. I'll take it up here. Oops. And it goes wherever it wants to. So we'll let it do that. The whole point of this, unfortunately, it works better with my laptop than with this one. The whole point of this is to draw a line on a piece of paper. And what's the shortest distance between 2 points? Straight line. Okay? And if you take a big huge sheet of newspaper and you have it sitting down, newsprint, and you have your team draw from every direction down to a single point, you take a look and see how straight the line is. Are the lines always straight? No. But what you want to do is get the team to actually see the fact that even though it's not straight, you want it to be as straight as you can. Because if it's here, there, all the way over here, back around and all that, all you're doing is wasting what? Time. And in a 6-week build time frame, plus school, plus all the other stuff going on, it's a miracle we get it done. And so QFD was a way of, on my team, was using to try and be better. Why? Well, I'm going to go forward here for just a second. Our rookie year was 2010. And we were known at our very first competition as the biggest losers. The reason why? We walked in, it's rookie team, we've got it, we're going to do well, put it up onto the scale, and the inspectors didn't know how to tell us. We were 152 pounds.
Whoa.
So immediately they say, do you have a battery on it? No. Is your no, you don't have your bumpers on it. Well, you're 152 pounds. We're 32 pounds overweight at our very, very first competition. So we spent that competition, and luckily we built a modular so we could take part of it off. We spent that whole weekend trimming weight. We took 40 pounds off our robot by the end of that week. And we finished out that year being 117th place. But there's got to be a better way to do things than show up 32 pounds overweight. The other thing we learned in that rookie year was make mistakes faster. We should have made that mistake a lot earlier than at the very first competition. The rules, we didn't kind of know the rules because everybody had seen it for the first time, so you had no memory, just what you saw. How many people here know all the rules? You guys have anybody in your team that their job is to know only the rules? Yeah, okay. If you don't have that kind of resource, then you're building something, you can't say, hey, how many motors can we have? How many sim motors? How many throttle motors? You need someone to know that. Instead of wasting time always looking it up. The other thing we learned was that you need everyone working together in the same direction, on the same page. If you have a hope and a prayer to have it done before, you have to bag that robot up, right? And it's pretty hard to do that. Do you guys build extra robots? Yeah, we built 2 this year. It's fantastic. So when the first one was done, we could still work on the other one and practice with the other one. But not everyone can do that. Also, a good phrase, trust but verify. It should work. Then you get out in a match and you watch your robots sit there and do nothing for the whole match. It should have worked. Everything was right, but they never verified it. And the last thing is, and this is the biggest joke we have, if we knew what we were doing, we wouldn't be here. No, if we knew what we were doing, we'd all have graduated and we'd be mentors now, right? So, building based upon this, we had to come up with a better way of designing our robots. So, let's see if this will take me back. Oops, doesn't like the computer. Let's try it this way then. Okay, so how do you accomplish this? Man on the moon. Carrier task force. How do you do either one of those? Is it one person comes up with the idea? 2 people come up with the idea? Is it only a few people working on it? A lot of people, right? 1,000, 2,000, 3,000, maybe even more. What's the cost of either one of them? By today's standards, kind of prohibitive, right? And if you make one very big mistake, such as you build an aircraft carrier with a hole in the side of it, and it doesn't work, you're kind of in trouble, right? Okay. Well, likewise, how do you accomplish designing a robot for a competition? Have you ever gone to a competition where you get there and your idea of the perfect solution is really off base? And then you go back and you kind of rebuild the robot overnight? Yeah? We've all been there. We've all done that. So, taking those together, we looked up the definition of systems engineering. And that's what it is. We have a lot of people building one gigantic, enormous project with lots of little moving parts into it. And it's a very complex system, and we have to have it done in a short period of time. Okay? Sounds like FirstRobotics. It's perfect for what systems engineering is. Now, system engineering works is you start out with the preliminary design, then you move to the critical design, and then a fabrication, and down to integrating and testing. Problem is, you get down here and you find out you have a fatal flaw. Is it easy to fix? No, it's very hard because you're almost done with it. But up here in the preliminary design, if you found a fatal flaw, it's really easy to fix. So it goes back to what we said earlier about make mistakes faster. The faster we find our mistakes and we make them, the easier it is for us to change them. Okay, so how do I get my team, who's the biggest loser, 32 pounds overweight, who really has a lot of heart, a lot of devotion, a lot of passion, how does the next year I get them so we can build the robot faster, get it done quicker, and we succeed? That's the real key issue here. So I started looking around, trying to draw on my previous knowledge, stuff that I've done over the years as an engineer now. And I remember being dragged to many different of the companies that we took care of in designing cutting tools to QFD seminars. So I started thinking about and started looking up that, and I talked with Mr. Debler and some others, and I said, well, maybe this might be something really good to make a difference. So if we look at this graph over here, Toyota was one of the very first companies to embrace using QFD. Why did Toyota embrace QFD? Well, during World War II, we kind of destroyed the Japanese continent, right? The island. And then after World War II, we went in there and we helped them rebuild. So they had to build all new factories and all new items. And they tried to make good products in that. Then we had a person here in the United States by the last name of Deming. Deming was really big on quality, how you can use numbers to make better products and things like that. He went to one company and they said, really interesting, very good. Sorry, we're not interested. He went to another U.S. company and they did the same thing, or they tried a little bit. But when he went over to Japan and told them about it, they said, sure, let's try it. This is great. This is fantastic. Because they wanted to compete on the same level as the United States. So Toyota was one that really embraced this concept. Before January 1977, they would spend about this much cost before they produced for pre-production of a vehicle, and then a huge amount, and then it would taper out. When they added a QFD in, they found out there was a lot more cost for pre-production, but the post-production was very, very small. The startup cost was a lot smaller. And if you notice, the time frame shrunk. See how long it took for them to design a car? Went from several years down to a few months, 18 months to 2 years. What does that do to a car company when they can reduce the amount of time that they can design, build, and produce a vehicle? Was it due in respect to their competitors?
Get the new products out there faster.
Right.
Beat the competition.
And it makes them very, very flexible. In robotics, well, how do you succeed in competitions? What do you have to be in order to succeed in competitions?
Flexible.
Very flexible. So I saw this and I said, well, this sounds pretty good. So I started doing a little bit more background onto it. And I went and dug up some papers and I got some files from some friends in that. And here is QFD as Ford uses it for Six Sigma. They use it to make the part even better than it was before. So a customer makes a complaint. They take a look at what the customer needs and wants are versus the technical metrics. Then they do another house of quality where they take the technical metrics and look at the product design characteristics, and then they bring that down and they do the product design against the manufacturing process, how they build it, and then they look at how they build it versus what controls they have over the build process. Does that look like a lot of paperwork? Yeah, it is. Okay, is that really important in building a car? Yes, especially when a car launches $5 billion. Is that important for what we're doing for robotics? No, we would spend the full 6 weeks doing it if we did it for robotics. It would be worthwhile, but we would spend the full 6 weeks and only have a couple of days in order for us to build it. So we shortened that. And what the Flying Toasters does is something a little bit shorter. We've taken all 4 of those steps and we brought them down to 1. We have our what's, which is the scoring opportunities and necessary attributes. What is it that we have to have on our robot in order for to go on the field? What was the number one thing in the rules that we had to pay attention to our robot this year? Size of your perimeter, exactly. That was very, very important. If it didn't match, you couldn't play. Okay? And we compare that against capabilities and features. What's one capability and feature that our robot can do this year? Autonomous, right? So there's 2 right there. So this column here is what? What is it that we're trying to accomplish? What is it that we have to take care of in order for us to play? Versus what are the hows, the capabilities, and the features of a robot? And we start comparing those. And I'm going to go in a little bit deeper on that. So we came up with a toaster design process, an official process for everyone. We watched the kickoff video and we fill out worksheets. And if you look at the packet I have right there and you scan through it, you'll find if you go farther down, you'll see actual copies of our worksheets. There you are, right there. So we pass out a 3-page worksheet before kickoff. And everybody has it in their hand. When the kickoff video goes, we watch the kickoff video and we do nothing on our worksheets. Because the kickoff video is really cool to watch. Right? Then you split up afterwards, you go back and to whatever area you have as a team, and we watch the video again as we write down the things on the worksheet, or we'll read the rules as we fill out those worksheets. Those worksheets are trying to tell us, get a good grasp of what's going on. Then, so we fill out our worksheets here, then we read and understand the rules. You're looking for two things, what the rules say, but more importantly, what the rules don't say, okay? Because there's a lot of good stuff in what the rules don't say. Because if it doesn't say it, you have to ask, can we still do it? Because once if you design around something and then later on they came on and say, oh, no, you can't do that, right? So we have to find out what they do say, what they don't say. You can discuss the rules amongst groups. What we do is we break out into small groups of 4 people, 1 mentor, 2 or 3 students, and they go through and they fill out these worksheets and they start looking at all the rules and they become experts. So everyone is an expert on the rules that day. We analyze the game, such as what's the offensive approach? What would be a defensive approach? Okay. This year was a cool one because of the fact you could build a robot that did nothing but do a 30-point climb and then dump the frisbees in the top for another 20 points. So you could actually have a robot that sit there just go up and then dump the 4 in there for a total of 50 points. Now you have to have someone bring you those 4, but it would work. So there's many different opportunities this year. And again, we take whatever we get from the rules and fill out those worksheets. From those worksheets, we then simulate the game. We clear out all the tables, all the chairs and everything. We measure out the perimeter, use some masking tape and all that, and we have people pretend to play the game, which is really, really good. It's a lot of fun. Everybody enjoys it, but since you're actually walking out and filling out the game and doing the game and everything, you really get an understanding of what the game is about. Okay? We're still going to get to QFD. Okay, now it comes down to the pre-QFD. We take a set of worksheets, which I have copies there for you, the scoring opportunities, necessary attributes. From our worksheets, from the rules, from what we've done for play and practice and all that, we now then go ahead and fill out that list. What scoring opportunities we have this year? Well, you can climb on the pyramid 10, 20, 30. You can shoot autonomous discs at 2 times the points, right? And you can put colored ones on the top of the pyramids, correct? Now there's also points that are awarded to the other team. What are those points awarded for?
Penalties.
Penalties and fouls, right? So if you bump into a robot that's attempting to climb, then that penalty could be 30 points, right? And if someone's in the loading station and you run into them and mess them up, that's points there too, okay? So those would be anti-scoring opportunities, but they would still be important for us to take a look at. Necessary attributes, we talked about the perimeter was a very good one onto it. So we fill out this list. What it is, the earning potentials, the strategic importance, okay, 1 being very low importance, 5 being very high importance. And then any comments we have, okay? Then the next thing we do as a group is, in our little tiny groups, is we brainstorm capabilities and features. What capabilities and features does the robot need to do this year? Okay? They can be generic. They do not have to be very, very specific, such as maneuverability, such as able to push, pick up off the floor, a hopper, things of that nature. And now it's time for us to put into the QFD, and we enter the QFD. So we're going to put all our necessary opportunities, scoring opportunities, necessary attributes over here, all our capabilities and features across the top. And we come together as a group at this point, and everyone builds the QFD together. This year we were very, very happy to have a couple teams come over. Chelsea came to our QFD, Brighton and Howell did too. Our QFD session is open to anybody because we're not talking about solutions, we're only talking about what's important about the game. So anybody can come join us for our QFD. Okay, so we start ranking them. So in the case here, this was last year's, which was basically we had the bridge that we could balance for competition, and we had the basketballs that would shoot into the baskets. So we would take a relationship such as, for here, bridge balance. Bridge balance and driver maneuverability. Is that a very strong relationship? If you can't maneuver your robot, can you balance on the bridge? Probably not. So it's very, very important. Is bridge balance important with driving over the barrier? There's no relationship, right? Has nothing to do with it. So we leave that blank. For drive reliability and bridge balance, there's a weak to moderate. So we put down moderate. Because if your chains come off and you're trying to go on the bridge, are you going to stay on the bridge? No. Okay? So you can see how we get real down to the nitty-gritty as to what the relationships are. Okay, once we have the relationships, we need to then go through and take a look at the impact versus effort. This is very, very difficult because there's usually a lot of heated debates about this. But ideally, we are looking for this region right here, 5. We want to give the littlest amount of effort, but the most amount of impact, right? Because what you don't want to do is do an awful lot of effort and get very little impact. You're wasting time, correct? And some things you spend an awful lot of time developing, and you still get a large impact, which is up in this corner. Can you think of one for this year where you spent an awful lot of time developing and you get a lot of impact, but it was very costly to get that impact? Anything off from this year's robot?
Climbing.
Climbing. Beautiful one. The launcher took a lot sometimes to try and get everything down. Okay? Once you have that, we fill in where the importance is, and you can go to our website, and I probably should introduce that right now. If you turn to the very back page of the packet I have for you, is our website showing you where you can get all this information. All our files are free and downloadable. And some of them are in PDF. If you want them in the original Word or Excel format, if you'll send me an email, I'll be more than happy to give you those files so that you can put them in. So our Excel spreadsheet does all the calculations for us. It takes a look at the relationship, multiplies it by the number of strategic important points, and that gives us our total absolute importance. And it creates a little graph off to the side so that we really quickly can see what's really the important things of our QFD process. Okay, and for last year, we found out that our critical what's was autonomous scoring, bridge balance, competition, not going past the 14-inch extension, the foul in the alley, the foul on the bridge, the foul in the key, picking balls up on the floor were important, and I can't see that from here. It looks like shooting hoops. Those were the most important things of the what's. And the hows that were very important was autonomous, driver maneuverability, pick up the balls off the floor, and teleop speed. Those were the most important capabilities our robot had to have. And we used this to design from. But our team made a mistake last year. We tried to do everything and be able to build one robot that does everything. Can you do that this year?
No.
Not effectively, okay? So on our third year, we improved upon it quite a bit. And we started looking at the ranking and, oops, a little too far here. And we actually looked for the epicenters. Where the two would cross, we highlight them as red. And they're a very dark color, and I believe there's an example there on the sheets there for you to see for this year. You take a look at it. So for this year, our team identified that autonomous scoring in the hopper, autonomous scoring, the shooter accuracy, and maneuverability were very, very critical for us. And by looking at just these points where the two connect, we have a total of 16 on this sheet, down from what? 50 on that last year. So we've designed to 16 critical characteristics this year versus 50 as last year. Made a big difference for our robot. Okay, so now we have the QFD. What do you do from there? It's time to brainstorm, right? Come up with ideas. Now, at this point in time, you're saying, well, that's an awful lot of paper we have to go through. Why don't we just start building and coming up with designs to begin with? What's really cool about this is, if you take a look at the QFD, and someone says, well, do we have to build a robot that has a hopper? No, but a hopper is important, right? Why? QFD says it is, correct? So it kind of helps you try and keep the team designing together, because they now know that these are the items the team wants to address. And we've got numbers behind them to know that they're valid, not like, oh, I just think that you absolutely have to have a 30-point climber. If you don't have a 30-point climber, you won't do well this year. That's not true. You don't have to have a 30-point climber to do well this year. It helps, but you don't have to have it. So then what we do as a team is people start coming up with designs. Now, all the way along, I have students that say to me, well, Mr. Weber, I got a cool design here. It's really hard. You tell them, write it down, do some sketches. Don't tell us right now. We're doing QFD. We have to do QFD before we look at solutions. Why do you want to do that? Why do you want to do QFD before you look at solutions?
Build a smart robot.
Well, it's true. You build a smarter robot.
What's important?
Exactly, based on important. You're not prejudged or biased. I don't know about you, but when I see something I have to build, as I'm starting to understand it, things come into my mind, right? And real quickly, you get an image in your mind of what the solution should be. It's way too easy to use that image as the final solution. Is it right? Sometimes it is, sometimes it's not. How many times did we change our solutions from the very first concept we have till the final one? Awful lot, don't we? Right? So it's best to have people write the stuff down, put the solutions off to the side, do the QFD. Now we compare those solutions back to the QFD. So if I have a solution here, A, we can take a look at how many of these categories it matches on the QFD. And then we can rank A with a scoring card. Oh, A's got 950 points. That's good. We look at B. Oh, while we compare it against the QFD, B only has a scoring point of 350 points. Which one's better right now? A's better, it's got more points. And then you can start doing that to all your solutions. Is it now saying your solution is good, but yours is not? That's got emotion into it. That makes people upset. It's, well, your solution has 950, we've ranked 950 points. Your solution, we only have 350 points. However, one of the things we notice on the QFD is your solution took care of this one area that yours didn't. So can we take that item off from yours and put it on your solution? Now what do you have? Exactly. A third solution is even better. And it makes it really easy because we take the emotion out of people that are good or bad, right or wrong, or things of that nature, and now we actually have numbers to tell us what is right and wrong and how to build it. Okay. And like I said, the best thing to do is check it against the QFD. Every time you make a change, my team immediately after Livonia, they wanted to come up with a whole bunch of changes for states. And they were going to build a blocker, and then they wanted to do a floor pickup, and they wanted to do a hopper extension, and they wanted to do something else. They want to put glow lights on the robot, and they wanted to have it do a certain set of symbols when it's scored, and you know, all kinds of things. Well, we took a look back at QFD and looked back at our results onto it, and we made choices of whether we were going to upgrade or not on our robot. Okay? So this is a good way of always keeping yourself grounded. Okay, questions? Any questions? Yes?
I have a question. You know, at following kickoff and you're reading through the rules and so forth,
Uh-huh.
about how much time do you spend doing QFD?
We do QFD Monday night at 7 o'clock after kickoff. So kickoff is at 10:30 on Saturday morning. So our team starts crunching numbers, goes back together to fill out all the information for QFD. They mull over the ideas and reread the rules on Sunday. We have school Monday, and then at 7 o'clock after dinner, we have all the mentors come to the classroom, and we do it from 7 until 9. We limit 2 hours.
That's about what it's,
Yeah, because if you don't limit the amount of time for QFD, it could be days.
it really lets you hone in very quickly on really where you should be going, where's your focus.
So do the students do this individually, then you said between the Saturday kickoff and Monday evening?
Correct.
They all do it individually, you all come together?
They fill out all the worksheets, they fill out the capabilities and features, they fill out the necessary scoring and attributes, all that stuff is all filled out. They can even do their own QFD, but we do it as a team together at 7 o'clock Monday night. Our meetings are from, our mentors usually get there about 6:30. We have dinner provided for everyone on the team, and then we do our work from 7 until 9 o'clock. Now students, after we get out at 2:13 at the high school, so from 2:13 until 5:30, students stay after and work on projects, but we don't have big team meetings until the mentors are there. A lot of our mentors work. I'm the only mentor that's a teacher. I hope that helps you out.
It does.
Okay.
It does.
Now, in the meantime, if they've got solutions, by all means, draw them, sketch them, record them, put them into another file. And since QFD is done, then you can compare them. Okay, because we don't squelch people from coming up with solutions. We just ask them that if they do come up with them, don't show them to anybody, don't talk about them until after QFD is done. Because we don't want to bias QFD. Okay?
I don't mean to hog questions or anything.
Sure, go ahead.
The team that just didn't hear the fighting pie and so forth, they did a practice I tried this year of students playing the game. Do you do any of that, like human play of the game and then do QFD, or is it just...
Yep, on Sunday they will meet, they'll go up to the library to meet, or they might meet over someone's house, go, with a large basement, they'll go through and they'll walk through the game. What we also do is, if time permits and we have availability, they will build a scale model of the field, and they'll build individual robots to practice it out with. So we've done that too. That's very effective. The real big thing is you want everybody on the team to, as quickly as possible, understand the rules, understand what's going on, know what's important early on. Okay, and one of the reasons why it's a big push for us is we have exams week 3. So if we're not into the design, past the design phase, week 3 when midterm exams happen for us, we're shut down because the school district wants everybody studying for exams to do well, and parents want their students to do well. So that's our week that we purchase all our items and we wait for that stuff to come in. So we have to know what we're building the Friday before exams. So we've got 2 weeks to go from rules to knowing what we're doing. This kind of puts a crimp in the style. I wish we didn't have exams. Then again, I know the students wish there was never a test. Yes?
The big thing, because I participated with this, the big thing that I see compared to how I've been involved before, it takes a lot of emotion out of it about your idea or his idea, this kind of thing. It totally diminishes that completely. You're really looking at it's really a mathematical solution. The only big thing that takes a lot more judgment is where you're ranking how things are difficult. This is more difficult to do than that. Experience, background, knowledge, things like that you bring to it. If you're an engineer for 20 years, yeah, you've got a little bit of an advantage about how easy is it to do something. So those kinds of things. That's where a lot of the judgment comes in. But the thing is, you're only, even if you're only off little bits at a time, not the whole thing. You don't miss the big picture. In other words, yeah, you might get something that you think would be extremely important. It may be somewhat diminished, but it's still going to be the top one, that kind of thing. because they're judgment, we're human beings, we make judgments, but it takes a lot of the emotion out, you know, what does everybody think about this idea, you know? Well, 90% want to do that. That's not how you design, and that's not how you do an effective design.
For those people, how many people have done engineering outside of the classroom? Yeah, I can tell. Okay, you automatically do this in your mind. You do assessment, risk assessment, you know which priorities, all that stuff it automatically happens. Why? Because you've already made mistakes and learned from the mistakes. The hard part is the high school student. You know, 9th, 10th, 11th, 12th graders. When I was in high school, almost 3/4 of my class, I grew up in a rural area. You had to fix the plow if you broke it. You had to fix the tractor if it went wrong. If your car didn't work, you had to fix it because we didn't have a lot of money. Okay, nowadays it's a whole different thing. I mean, students are driving better vehicles than I'm driving to the high school. Okay? So when it gets to this point, they've never had to, or very few of them have had the chance of making big blunders and learning from them. We don't have time to make big blunders. So one of the easiest ways that I'm finding is QFD takes that person who's never had that kind of school of hard knocks experience, and we can transfer the information to them on how to bypass that and learn from our mistakes by using QFD. Okay? Now, if you want to look at it from a pedagogical, front brain, left brain, right brain type of thing, they say research has indicated that the average teenager doesn't have the frontal lobe developed until about the age of 21, 22. This here is teaching that development of the frontal lobe. There is a whole big set of strategies from Marzano that supports this type of a direction for happening in the classroom. I actually use this in my robotics class and my engineering class. My students do this in class whether or not they're on the team, just to give them an idea on how to be able to use numbers to evaluate a solution and come up with a good answer. And it makes a big difference. Any other comments or questions? Yes?
But I would like you to go over one more time the difference between the 2012-2013 season of your QFD chart. You said you went to the red blocks. Can you go over again? I just didn't quite get it the first time.
Okay.
How you highlighted them.
Let me reset this. See if this will take me back. Okay. In our 2012 season, we looked at these items being the most amount because the graph generates on the side. We take the actual percentage and turn it into a bar graph. So it's easy for students and people to see. So what we did in 2012 is we figured this whole line was important. And so every one of these squares that were highlighted is what we tried to design a robot to accomplish. Okay? Which was a tremendous amount of things to try and do. We ended up having 15 Jaguar Victors on a robot with, I think, 15 motors, and we were, I mean, it was a phenomenal robot. I don't know if you saw it here earlier. Let me back up to it. Oops. One or two more. Right here. This robot here not only picked up off the ground, it shot out the back for three-pointers, or the front end actually pivoted up to shoot out the front for autonomous onto it. So we could do 1, 2, or 3 shot baskets. I mean, it was technologically, it was wonderful, absolutely wonderful. We had a flail that dropped down in front to get them out of the corner, to get them out of the side. We had a ram on the front end here. Then when it dropped down, it would push the bridge down for us to get in. It was fantastic. The thing that we learned is because it had so many bells and whistles and it did so much, and it wore the drive team out, and the drive team fatigued in that 2 minutes, 15 seconds. By the end of the 2 minutes, 15 seconds, they were whipped. And then if they had to go back and do it again, we could only get one drive team because it required so much attention to drive it, drive the vehicle, that we had to have the best out there every single time. So by the end of one day, that Friday, the drive team basically was laid out dead. They would go home, sleep the whole night, come in Saturday morning regretting wanting to ever use the machine again because it took that much energy from them. Well, there's an old famous saying, you want the machine to do all the work and the man to manage. That was the opposite we did last year. So this year, we took a look at what was really critical, and it was the epicenter. That's where the two columns met, and that's why we highlighted those in red. That was where the very, very important things was going on. So we designed to those epicenters rather than that whole bar. If that makes any sense. And doing so, I don't know if you saw our robot, it's very small, very agile. We can target 180 feet. We can put it into a kiddie pool at 180 feet. All the shots, we're taking the paint off the side of my classroom, shooting 80 feet. The Frisbee comes out at 95 feet per second, which is 65 miles an hour. That's what we're shooting from. It's highly accurate, but it's a very simple robot because we went to those very important traits that QFD pointed out. Now, once you master those traits, it doesn't mean that you're done. If we had a lot more time, a lot more resources, and a supplier or a sponsor that wanted to come in with $1 million or even $20,000, we would take it. And if we could buy more equipment or have some equipment at our disposal more than what we have, we could have made a more complicated robot and gone farther down on the tier. But we build our robots in-house, as well as I'm sure most of you do. Yeah. Any other questions of that? I want to make sure there's plenty of time, because usually there's a lot of questions with QFD. One of the things about QFD is you're going to have the naysayers. The people say, that's just paperwork. That's just busy work. Yeah, it's paperwork. It does look like it's busy work. But when you're all done and down with and finished with it, and you put it up on the wall, and every time you design or you do something, you walk back and take a look at it, it is an anchor, because the team always keeps coming around knowing what's really important. It's time well spent. But don't spend a week doing it. Don't spend more than 2.5 hours. If someone gets down to a 10-minute debate over whether or not autonomous has anything to do with driver maneuverability, or drive maneuverability, at a certain point you have to cut it off and move on. You can come back and revisit it, but you got to keep them moving through QFD. Because you can get lawyers into the group that start really nitpicking and finding the fine lines. You're not looking for that fine of a line. If it's that fine of a line, you might want to break down that line into more subcategories. Such as the pyramid this year. We started out with just the pyramid climb. And real quickly, on our QFD, we realized the pyramid climb this year is really two components. The 10-point component and then the 20, 30-point component. Right? All you have to do is get off the ground in order to get 10 points. How much effort does it take to get off the ground? Not much. You get 10 points. Now, to get 20 points, how much effort? Well, you got to go over 30 inches. That's a lot of effort, right? So we split it up on this year's, we ended up splitting it up on QFD. Now, sometimes QFDs have to be, you have to go back and revise them with new information that you gain, such as rules could change. Whenever you get a team update, you need to take a look at the team update back to QFD to make sure it's still valid. Because they could change the rules on us and make it completely different as to what it's, it's waiting. Okay. Any other questions? Everyone get worksheets? Like I said, if you take a look at the back page, this is our website. We've got a lot of resources on our website. There's one section on QFD. All these files that you see here are available to you. Now, like I said earlier, some of them are PDF form just for the size so that you can download them. But if you want the Word file or the Excel file or whatever was generated, even the PowerPoint, this PowerPoint here, I'm more than welcome to give it to you. Just drop me an email and I'll email the file to you. And if you're anywhere near South Lyon, that Monday after kickoff, you're welcome to join us. Like I said, we had a blast. We had Chelsea there. And the Chelsea team absolutely had a lot of fun working out with us. We had a couple representatives from Howell and Brighton too. And they took quite a bit away from it. In fact, Chelsea went back and then the next day they brought in the rest of their team and they redid QFD for the rest of their team. So. Anything else? All set? Okay, if you have any individual questions, I'll be more than happy to work with you. If you have any questions at all, thank you. Just let me know.